Hi everyone. So today we are going to solve another problem. The problem code is CLETAB, CLETAB from CODECHEF. So let us see what the problem is. The problem is called as cleaning tables. So let us read the problem. The chef has to clean the tables for his restaurant. So whenever a customer wants a table, he must clean it. But he is lazy, so all the tables are dirty. The customer don't leave the table unless they are requested, and also the customers can order meal again. So if they are having a table, they can be served the same table, so no need to clean it again. But if they don't have a table, they must be given some table. Okay, fine. The restaurant has n tables, and from a customer can occupy an unoccupied table, right? However, if all the tables are occupied, the chef must choose to pick a customer and to leave, and the free table is given to the customer. So the chef has some ability to tell the customer about the meal request of entire day. So given the list help the chef to find the minimum number of times he has to clean the table. Okay, so what the problem is, there are some n tables. So there are some n tables here. They are given n tables and m number of customers and m customers. So we have to find the minimum number of times the chef is required to clean the table. Okay. Now the next thing we need to see is that whenever a new customer arrives, he must be given a table which is free. Also, if the customer repeats his order, there is no need to clean the table. Okay. Also, if the customers are more than the tables in the restaurant, so then the chef must pick some customer to leave, and that free table must be given to him. So if you observe this more carefully, wait, first let us tell me, I will tell you the input format. The T is the number of test cases, then two lines are N and M, that is number of tables and customer orders, and the next time line contains the orders of customers by reference by integer C. So see, there are four test cases, this, and then N and M. So there are two tables and four customer orders, like numbered from 1 to 3 and 4, like that. Three tables and two customer orders, three tables and six customer orders, like that. And we have to find the minimum number of times we need to clean. If you observe this question more carefully, this would look like some page replacement algorithm, right? Mostly you can say like some optimal page replacement algorithm, where the number of tables will tell you the number of frames, and the number of orders will tell you the page request. So whenever there is an empty page, you need to that will be compulsory a miss. And whenever the page request is repeated and if it is present in the frame, that will be hit, so no need to clean. And if we want to and if this frames are completely full and another request arrives and we want to change that, so we look further away in the future, like we do an optimal page replacement algorithm, and we change that page which is least required. Let us simulate this and see. So we have here n customers and m tables for first request. So here we have two frames, right? For the first test cases 2 and 4. So here we have two frames here. The first request is 1, the second request is 2, these two compulsory misses. Then 3. Now for 3 we look away in future which is required, but there is nothing. So this is 3, and then again 4. So total 4 requests are required. As we see here, the output is 4. Now let us see this 1, 3 and 6. There are total 3 page frames, 1, 2 and 3. And now a 6th request. So first is 1, then second is 2. Now 1, it is already hit, so no need to clean. Then again 3, then afterwards 4. Now to change the 4, we see which is required list in future. So I guess 1 is required, so after 1, so we remove the 1 and we choose anything else. So let me keep this, and you have here 4. So total 1, 2, 3, 4 requests are required. So I hope this explanation was clear. I will tell you the similar in code. So let's check the code here. I will just do it so you can see. So first what I am doing, I am taking the tables and the order of tables as their input here. Tables and the order of the tables as the input, that is n and m. Then actual orders whatever I am getting. So occupied will be my array which contains the occupied tables, and cleans will be number of times I'm cleaning. Now I will iterate through them. First I will check if that order is already present in occupied. If the table is already occupied and the same order is asked, then I will continue. Else if this is a new order, I will add my cleaning, so I have to clean it, so I will do +1. Now that for the same order I'll check if the number of tables are still free. So I will add them to my occupied. Like in this example, when I had 3 frames, so for order 1, 2 and 1, still my 1 frame was remaining. So for when the third order came, I just added to my occupied array and I continued. Now if I come past this line, it means that my number of orders have exceeded the number of tables. So what I'll do, I will make a set of my occupied orders, because this contains this contains the occupied array and it may contain repeats, right? So what I'm doing, I'm having my set here. So now I will check in future orders. So whatever I did that time, I check in the future and I just go on removing them until and unless only one is left in my array. Until unless only one is left in array. And now what I do, I just remove the only order left in my temporary array and I append my actual order. So basically it is the same what I did in my simulation, and with this we get the answer. So I hope you got the logic. If you have any doubts, you can post in comments. Also here, instead of list, you can do a set, so that the time might get increased, so the time might get decreased. So that's it for this video. Do like, share and subscribe. Thank you.